All right, welcome. This is 10.2, graphing using tables or slash standard form. So today we're going to get into actually graphing a quadratic. Again, this is the standard form for quadratic. Y equals ax squared plus bx plus c. And we're going to learn how to graph from that form. And then in the future we'll be talking about different forms that are easier to graph with. Okay? So A, B, and C, those are just coefficients. They're just numbers. C is a constant. You can graph equations by filling in this table below. Okay, so we're gonna fill in this table and graph. All right. So for example 1, we have y equals x squared minus 4x plus 3. All right. So we could try lots of different things and see what this works. I mean, we could start with 0. Let's see what happens if we plug in 0. So if x is 0, then we'd end up getting, we plug 0 into the x's, we would get 0 squared minus 4 times 0 plus 3, and that's just 3. So now we'll plot that up. 0, 3 would be right here. Okay. Maybe we'll try 1. So 1 squared minus 4 times 1 plus 3. That's just 1 minus 4 plus 3. So that would give us 0. So at 1, it's 0. Alright, we could try 2. 2 squared minus 4 times 2 plus 3. That would give us 4 minus 8 plus 3. And that ends up giving you, you just plug that in your calculator if you needed to, and that ends up giving you -1. So we have a point here. Okay, we can keep going. We can do 3. That would be 3 squared minus 4 times 3 plus 3. That gives us 9 minus 12 plus 3. You could plug that in your calculator. That ended up giving you 0. Then we could try 4. 4 squared minus 4 times 4 plus 3. That gives us 16 minus 16 plus 3, which gives us 3. Okay, so we can kind of see this pattern. It started at 3 here, and then it went to 0, and then it went to -1, and then it started going back, 0, and then 3. Okay, that's what quadratics do. They are symmetric. So once you get to the vertex, and we've talked about the vertex last time, it starts going back up again. Okay, so our quadratic is going to be something like this. Do your best to do your, I guess since you're going to be doing this online, it's a little different, but you're going to be doing problems like this too on your homework today. But it'll be probably a little easier. Okay, so that is how you graph quadratics. We can try another one if we'd like. Why don't we, let's give that a try. We'll probably skip some of the others, and then I will go back to that at the end if you're good, or if you need extra help, okay? So here, let's try again. Let's try 0. If we plug 0 in, I just leave some space above because I don't know which way I need to go to be able to find our vertex. So I kind of just guess 0. That ends up giving us -0 squared plus 6 times 0 minus 5. Well, that just gives you -5. So at 0, it's -5. So right here. And then let's see which way should we go. Maybe we'll try, let's try -1. So we get negative times a -1 squared plus 6 times -1 minus 5. Okay, just remember this, when it's being squared, whenever you plug something in, especially if it's negative, put a parenthesis around it. Probably should have put a parenthesis there too, just so you don't, and I would plug this into your calculator if you can. Okay, oftentimes if if you do it by hand, perhaps you'd run into sign mistakes or things like that, okay? So we end up getting negative, and then a negative 1 squared is a positive 1, plus, or I guess it'd be negative 6. So 6 times a negative 1 is a negative 6 minus 5. And that ends up giving you, what would that be? Minus 12. Okay? So negative 1 comma negative 12. Well, that would be like way down here. Okay? So I guess I kind of went the wrong direction. That's okay. So we'll try doing positive. So let's try x equals 1. That gives us negative 1 squared plus 6 times 1 minus 5. So that gives you a negative 1 plus 6 minus 5. That gives you 0. So we'd do 3 comma 0. Alright, and then we could try 2. Negative 2 squared plus 6 times 2 minus 5. That gives you negative 4 plus 12 minus 5. And that ends up giving you 3. So we got 2 comma 3. We could try 3. That gives us negative 3 squared plus 6 times 3 minus 5. That gives you negative 9 plus 18 minus 5. And looks like that would give you 4. So we've got 3 comma 4. We could try 4. Negative 4 squared plus 6 times 4 minus 5. So that would give you negative 16 plus 24 minus 5. Looks like that ends up giving you 3. So 4 comma 3 would be right here. Okay, and again, like I said, quadratics are symmetric. So now that it's going down, we know our next point would be right here. And then our next point would be right here. Alright, so from there we can graph our quadratic. You don't even need to plot every single point, or you don't have to plug stuff into your equation in order to graph. Okay? Again, this is your axis of symmetry. These are your x-intercepts, just a reminder. This would be your y-intercept. Okay? This is the vertex. The maximum would be 4. The x value that gives you that would be 3. I think that's pretty much everything we talked about. Oh, and it's also opening down. So sometimes they'll talk about quadratics or parabolas that open down or open up. Sometimes they also say concave down or concave up. So same sort of thing. It's just the concave is kind of like the shape. So I think on math space they talk about concave up or concave down. Alright, so there is an easier way to do this than just checking and guessing, or guessing and checking, is this equation right here. Okay, so this formula, x equals negative b over 2a, that is always going to be your axis of symmetry. So that way we can find that critical point, the vertex, and then we can plug in values that are next to it. Okay, so we're not just shooting out in the dark. Okay, so for example, this one, again, this is ax squared plus bx plus c. Alright, so in this situation, a would be 1, and b is 4. So we'll plug that in, we'll get negative 4 over 2 times 1. So that gives you negative 2. So negative 2 is going to be our vertex. It's also, again, it's our axis of symmetry. This would be the axis of symmetry. So negative 2 would be something like right here. X equals negative 2. That would be the axis of symmetry. And then we need to find the value. So if we have an x and we want to find the y, again, we plug that into our function. So we'll plug negative 2 in. We'll get negative 2 squared plus, b is 4 times x, which is negative 2, plus 2. So we'll end up getting negative 2 squared is 4, minus 8 plus 2. And that ends up giving you, what would that be, negative 2. So here is our vertex. Okay? So now we have our vertex, we can find one that is next to it. So we could do like negative 1. So negative 1 squared plus 4 times negative 1 plus 2 is equal to, okay, that gives us 1 squared is 1, minus 4 plus 2. And that ends up giving you, looks like, negative 1. So at negative 1, it's negative 1. Okay? And then we could do negative, or I guess it'd just be 0. Let's do 0 next. So 0 squared plus 4 times 0 plus 2. Okay? That will give us 0 plus 0 plus 2, which is 2. So 0, 2 is right here. Okay, so we can kind of we're starting to see this parabola. Okay, and since parabolas are symmetric, we can also put the plots that are on the opposite side too. Okay, on your homework, well, I guess I keep saying this, since you're not in class, this is going to be a little different, but in the past, I always ask students to at least do 5 points. So that would be sufficient. Okay? So now we found a rule so that we don't have to just guess. All right? We can find the vertex, and we also learned that parabolas are symmetric. So once you do it to one side of the axis of symmetry, you can just mirror it over to the other side. Okay? So I will leave this for later. Okay? Same as this. Okay, just make sure has a spot here for you to do. I'd like you to try it by yourself if you would, too, as well. Okay, so find the x value of the vertex. Okay, aka the axis of symmetry, and then you're going to plug that in to our function to find the y value for our vertex. Okay, and I'll go over these after the end of the video. All right, so. It says now if only we could get rid of the table, okay? So there actually is. If we notice at these graphs, okay, there is a pattern. Okay, we start at the vertex, and every time we go over 1, we go up 1. And then we go over 1, up 3. And then if we went, so this would be 1, 1, this would be over 1, 3, and then the pattern continues going. You could go over 1, up, this time you go up 5. So 1, 3, 5, okay? That's a pattern. So really, once you have your vertex, you can just use that pattern, okay? So this is the pattern. You go over 1, up or down 1 times A. All right, in all of these situations, A is going to be will be 1 or negative 1, okay? And then next we'd go over 1, up 3A. And we'd go over 1, up 5A. But again, you really only need to do the 5 points, okay? You're going to go up if A is positive, and it goes down if A is negative. Okay? But this is kind of built into this, what A is. Okay, so for this example, problems A, okay, the A value, what's in front of that x squared, is just 1. All right? So once we find the vertex, then we can just use the growth pattern. Okay? So this is the growth pattern for quadratics. 1A, 3A, 5A. Okay? So I'll give you an example. Here we want to first find our vertex. So we'll need to find the x value for our vertex. So we'll do negative b over 2a. So we'll do negative 6, because b is negative 6, over 2 times a, which is 1. So that gives us 3. So our axis of symmetry here is going to be 3. Somewhere on this line is the vertex. All we need to do is plug that in, plug 3 into our function, and it will give us our y. So we'll plug that in. Y is equal to 3 squared. Let me zoom in a little bit for you. Minus 6 times 3 plus 6. So that gives you 9 minus 18 plus 6, which gives you 2. Okay, so we find our vertex here at 3, 2. And there, since a is positive, we'll use our growth pattern. We'll go over 1, up 1, because a is positive, over 1, up 3, and then we're just mirroring over to the opposite side. And that's all there is to it. Okay, so let's give another try for D. Alright, first we need to find the vertex. So to find the vertex, we find the x value of the vertex, which is negative b over 2a, which gives us a negative 1 over 2 times, or sorry, b is 2, so here's b, a is 1, so negative 2 over 2 times 1, that ends up giving you negative 1. So our axis of symmetry in this situation is negative 1, and then to find the y for our vertex, we will plug negative 1 into it. So we'll do negative 1 squared plus 2 times negative 1 minus 5. So that gives us 1 minus 2 minus 5, which gives us negative 6. So that would be like 1, 2, 3, 4, 5, 6 right here. Okay? And then since a is positive, we'll go over 1, up 1, over 1, up 3. And then you could continue going if you wanted to, over 1, up 5. Okay? It just goes over 1, up, and it goes by odds. So 1, 3, 5, 7, 9, you could keep going as far as you possibly could. Okay? If I make any mistakes on these videos, please let me know, and I'll give you extra credit. Okay? You could also check your answer. You could plug 0 in for x, so you get 0 plus 0 minus 5. So you should get it 0, you should get negative 5, which here we've got that, so we're good with that. Okay? Here's some other examples. Perhaps we'll finish this last one together, and then maybe I'll just make a second video if you want to go over that. Okay? So it says graph the parabola and then identify all key features of the graph. So we do kind of the same thing. We'll start with trying to find the vertex. So first we'll want to find the x value for our vertex, which is negative b over 2a. And again, this is also the axis of symmetry. So b is 6, so we'll do negative 6 over 2 times a, or a is 1. So that gives us negative 3. And then the y value for our vertex, so this is our vertex, would do negative 3 squared plus 6 times negative 3 plus 5. So that gives you 9 minus 18 plus 5. This looks very similar, like we've done this one before. Anyways, and this ends up giving us negative 4. So our vertex is negative 3, negative 4. Negative 3, negative 4, which is right here. And then we can just use our growth pattern to find all the other points. Okay, so we'll go over 1. Since a is positive, this is a positive 1. We'll go over 1, up 1, over 1, up 3, over 1, up 5. And then we can just mirror over the axis of symmetry, which I didn't write down this time, but okay. So that is the lesson. Okay, and I'll make a new video to finish in. Oh no, sorry. Let's fill this in. Okay, so it says, what is the y-intercept? Okay, well that is 0, 5. Hint: if it's in standard form, this is the y value for your y-intercept. Okay, the constant is the y-intercept. Because when you plug 0 in for x, that gives you the y, which will be 0, 5. Alright, good to know. X-intercepts, looks like we have one at -5, 0 and -1, 0. The vertex here, this is the vertex, is, we already wrote that down, -3, -4. Again, this is the x-intercepts. And this is the y-intercept. Okay, axis of symmetry, that was the very first thing we found, is x equals -3. Is the vertex a maximum or a minimum? It's a minimum. Oh, and what's its value? Its value would be -4. The x value that maximizes or minimizes the function, well, that's the -3. It's what you need to plug in for x to give you that minimum. Okay? And then direction of opening here is up, or you could write down concave up. Either way would be fine. Okay? Alright, well, if you have any questions, please let me know. Send me an email. If there's certain types of problems we need extra work on, I can make another video. We could also do like Google Hangout or something like that if we need to as well. Alright, we'll see ya.